Currently, the ANSI-ISEA 105-2016 standard, which is voluntary, mandates the use of the ASTM F2992-15 test method. This standard specifies that 3 gloves be tested. The method requires that a swatch of the glove palm or sleeve is mounted on a curved surface. 15 individual blades are tested at 3 different weights, 5 blade passes per weight, each on a different section of the glove palm or sleeve swatch. The test measures the weight in grams required to cut through the fabric on a 20 millimeter pass, or roughly 3/4 of an inch. This chart shows the ANSI-ISEA 105-2016 cut levels, cross-referenced to pounds. Note that a cut level A6 glove withstands approximately 8 pounds of pressure on a 20 millimeter pass, or approximately 3/4 of an inch. Do you have an edge in your facility that weighs less than 8 pounds and has a potential edge travel less than an inch? In Europe and in many other countries, the EN 388 standard is used. EN 388 2003 is still in effect until April of 2018, when EN 388 2016 officially replaces it. These test methods are similar. The tests use a circular blade and measures the number of rotations required to cut through the fabric in the same area of fabric. Cut levels are then assigned. Neither test measures force. Only tensile strength can stop the force of the cutting edge. Here are some examples. This is an ANSI cut level A9 glove being subjected to a piece of titanium metal. It cuts like butter. Why? Because the glove did not have enough tensile strength to stop the force of the rough edge of metal. This is an ANSI cut level A2 glove. After multiple passes on the same titanium metal edge, there is no cut through. That's because this glove has ultra-high tensile strength. The EN 388 standard has a tear test that measures the strength of a section of fabric, but the highest level is 75 newtons. The Dynamax HD yarn in this glove has a single-strand tensile strength of 168 newtons. Here is a piece of crock glass. Notice the glass beads on the surface. When this glass is cut, they form razor-sharp edges. This is an ANSI cut level A4 sleeve. One pass, it fails. Why? Because the yarn in this sleeve had only 60 newtons in tensile strength. This is an ANSI cut level A2 sleeve. After multiple passes on the same crock glass edge, there is no cut through. This sleeve was knitted with Dynamax HD yarn, which has a single-strand tensile strength of 168 newtons. This is an ANSI cut level A6 glove. The knife blade cuts through both sides of the glove. This model glove was knit with a spun yarn, not a filament. It had a dulling action but lacked sufficient tensile strength to stop the force of the cutting edge. In the United States, OSHA 1910.138b is mandatory. In simple terms, it states that it is the responsibility of the employer to evaluate the hazard and select the proper protection to protect the employee from that hazard. The only way that we know to comply with OSHA 1910.138b is to edge test. The best way to perform an edge test is to wear proper safety equipment. Select the hazardous edges in your facility. Take them to a secure area and vise them to a stable surface. Measure the potential length of exposure. Since coatings are designed to grip, use the fabric side of the glove to edge test. Make sure that you use the entire width of the glove or sleeve that you are testing. If you use the edge of the glove or sleeve, it will not replicate how they are actually used. The glove or sleeve should be subjected to multiple passes to replicate its typical use. We recommend that a video be made of all gloves tested in order to have proof of compliance with OSHA 1910.138b. Keeping an edge from moving is as important as the cut resistance itself. Therefore, the next step is to test for grip. Cover the edge with the lubricants being used and check the hand force needed to get a good grip. In general, nitrile-coated gloves work best in hydrocarbon-based lubricants, but become slippery in water-based fluids. Latex and PVC work well in water-based liquids, but can deteriorate in oily solutions. Polyurethane provides an excellent grip in oily, wet, or dry conditions.